Hi, everyone. So we're going to pick up with mixtures of matter. So mixtures of matter are combinations of pure substances. So remember, pure substances are things like elements and compounds. Um, so when you look at something in the world, it can be either a pure substance or a mixture of pure substances. So some prefixes you need to know to classify your mixtures are homo, which means same, as in like homozygous or homogeneous milk. Um, and homozygous just means that it's the same alleles for a trait. That's a biology term. Hetero means different or other. It's Greek. Heterophilous means having different leaves. So when we're talking about it in terms of matter, homo is going to be homogeneous or or homogeneous. So it's going to be things that aren't easily like separated. And then heterogeneous are going to be things that you can easily see to separate. So homogeneous mixtures can be aqueous solutions like lemonade, solid solutions like steel, or gas mixtures like air, right? You can't really separate out the different types of molecules in the air, even though it's not all pure oxygen, right? It's mostly nitrogen. Heterogeneous mixtures can be solids like gravel, liquids like blood, where you've got two different like density liquids in there. And then it can be combinations of more than one phase as well. So it could be like a slushy where you have ice and liquid. That's technically a heterogeneous mixture. Okay. So there's a flowchart for identifying matter in your notes. And the first question you have to ask yourself is, does it have mass and does it take up space? If it has mass and takes up space, then it's definitely matter. If it doesn't have mass or it doesn't take up space, then you're looking at some form of energy. So once you've determined that you're looking at matter, the next question you have to ask is, can it be separated by physical means? Here. If the answer is yes, then you have a mixture. Once you know you have a mixture, then you have to identify whether it's a heterogeneous mixture or a homogeneous mixture. So you ask yourself, are individual substances in the mixture distinct? If it's yes, you have a heterogeneous mixture. So think things like gravel, blood, and um, just milk straight from the cow. Okay. Um, and so milk in its normal form, if you let it sit for a little while, either in a fridge or on a counter, the fat will separate from the whey. So you'll have this layer of like thick fat, and that's what they make butter from and cheese and stuff. And then the whey is like the liquidy part, right? So we actually treat milk nowadays. If you buy store-bought milk, it's called homogenized milk, right? And it's pasteurized for safety. Homogenized just means that it's been treated so that that fat doesn't separate out anymore. Now, if the individual substances are not distinct, you have a homogeneous mixture. These, like I said before, are things like lemonade, gasoline for your car, and steel. Okay. Homogeneous mixtures aren't easy to separate out. If you let it sit, it's not going to become two separate liquids or two separate solids. It's going to stay in the mixture. And so you need different techniques for separating those out. If you cannot separate something by physical means, then it's a pure substance. Okay. And then the next question you have to ask is, can I chemically separate it? Can it be separated by chemical means? If the answer is yes, you have a compound, things like salt, baking soda, and sugar. If the answer is no, you have an element. Those are things like carbon, tin, and oxygen. Iron and gold were the examples we used in the last video. Okay. And remember, elements are something that is pure. It can't be broken down any further by chemical means. It has an element card on the periodic table. Compounds are made of elements, and homogeneous mixtures and heterogeneous mixtures are made of different compounds and elements put together. Okay. So now we're really quick going to talk about different ways that we use to separate mixtures and pure substances. So we use filtration, mostly to get solids from liquids, distillation to separate different liquids. Sublimation can let us get two solids apart. Um, and so if you think back to phase changes, sublimation is where something goes directly from a solid to a gas. And solids do those at different points. And then maybe one solid doesn't sublimate at all. So that lets you separate two solids in a solution. Chromatography lets you get gas from a gas or a liquid from a liquid. I'm going to show you picture examples on the next slide. And then the last one is crystallization, lets you get a liquid from a liquid. So if you have two liquids in solution, right, and one of them crystallizes at a specific temperature and another one does not, then you can use that to separate them out, kind of like the ice and the slushy, right? You can separate out the ice because it's a solid now. But if it was all just melted slushy, it wouldn't be a solution anymore, right? All right, so here in the center is your filter diagram. So if you have a mix of water and sand, you can put some filter paper in a funnel. The water will go through the filter because it's smaller than the pores in the filter paper, and you'll catch the sand. Okay. Distillation, water or liquid from liquid. You'll heat it up to the boiling point of one of the liquids, the one with the lower boiling point, and it turns into a gas. It travels down a condensing tube, which turns it back into a liquid. But remember, the higher boiling point liquid's still hanging out in the flask, and then you'll collect it in a new container. Sublimation, which is this guy over here, this is dry ice, right? So remember that's a solid going directly to a gas. There's not a really good picture of that as like the process itself, so it's just a picture of something sublimating. Chromatography, so if you look at this picture, you've got different colors of dye and you can see they're traveling up the paper. And so this one, two, three, fourth from the left is yellow and blue, and that was originally a green color. So you can see where it's separating out. The same thing here with the red. You can see that there's like a red, and then up here at the top there's an orange, right? And so this paper is specially made so that it helps separate out those dyes. It's got a certain size weave to it, and some dyes will pull out before others. And then the one on the left here, so this is actually copper sulfate, and I know it looks like rock candy. You could do this with rock candy. But this is copper sulfate, and you can see that it's in a solution in the cup, but as this person is pulling it out, right, you can see that it's crystallized on the string as well. All right, so go get the handout for the types of matter classifications and give it a shot.